Welcome to Module 12, Supervised Machine Learning Classification, K Nearest Neighborhood. In this model, we will present the KNN method and we'll demonstrate the application of such method based on a case study of equipment criticality classification. As we previously demonstrated, we started with the glossary of the main concept of artificial intelligence applied to maintenance 0.0, such as artificial intelligence, machine learning, unsupervised machine learning, supervised machine learning, supervised machine learning classification, and supervised machine learning regression. In this model, we focus on supervised machine learning classification and more specifically to the K nearest neighbor method. Concerning all different types of application of artificial intelligence for maintenance, the one that we'll focus in this training is machine learning, and specifically the supervised machine learning. As we already mentioned before, machine learning methods use data sets, data, and split the data in training and test data. So we split 70-30%. In the 70% of this training data, we use to training our model. In the case that we are discussing in this model will be the K nearest network. Based on this model, training by this training data, that's 7% of our data set, we've got a result that we can measure the error. In terms of classification, we'll look on our confusion matrix as the main answer and possibility to check and to assess the error of our model. However, we already have 30% of test data to test our model and verify if the error of the model is acceptable and if the model are not overfitted. That means fit very well to the training data set, but not very well to the test data, new data. Since the error of the model are acceptable, we are using new data sets similar to the previous one to validate the model. And since the model is validated, we can continuously using similar data sets from similar equipment, for example, based on the same model to classify our data sets. The classification model have the same concept that's machine learning, but we use in a classification model as the main model that we have. Then the model will classify different data in different categories. So category is one of the important characteristics that we have in our model. In the neural network, we saw that we classify the data sets in 0 and 1, but here we put categorical names for our data sets. Therefore, we use a previous data set, a data set with already defined classification. Then, based on this classification, the classification model, the K neural network, will learn how to classify such information, and later on, by verifying based on the 30-25% of the data sets, we verify this model. If it's not overfitting, we use new data sets to validate this model. So here is a type of example that we have as classifying equipment in terms of criticality. So we have catastrophe level, indifference, and moderate. So despite having different colors that we have used to apply when you perform safety analysis, for example, in safety analysis, the red color is the worst one, is the catastrophic, is the one that we use to classify catastrophic events. Here, that's just the colors. We need to be aware that for our catastrophe, we are using blue. For our moderate, we use the orange, and for our indifference, we use the yellow. We can have actually use different colors, depends on how we define that. Just to not pay attention on it in this classification here, how we define the color should not be confused in which equipment we are classifying. Then, of course, the highest level of criticality are are applied and classified for vessels, towers, um, and these tanks, this type of equipment, furnaces. And here in the middle we have a compressor or heat exchanger, and of course with lower criticality we have pumps, we have valves, we have other equipment. The key nearest neighborhood aims to classify a new data consider a set of data that are already classified based on previous data sets. So therefore, the new data are compared to k closest point based on distance between each data point. So let's consider that we have these data sets with different colors. We have three classes A, B, C, represented by the colors blue, red, and violet. And then we have a new point yellow here. So how to classify this point based on k nearest network? So if we define k as 3, as 4, let's put as 4. So the distance between this new point to the 4 closest point will be compared. So we have one here, we have another one here, we have another one here, and we have another one here. So among these 4 points, the points that are closest belongs to a class C. So this point here will be classified as C because it's closest to points that are belongs to class C. So if we have a new data point here, this green one, and then we define K as 5, so we define the closest 5 point that we consider is 1, 2, 3, 4, and here 5. So we can see that the closest points are in the class B, so this point will be classified as B, and then so on. That's the general process of K nearest neighbor. So we have 3 methods basically that we can apply for calculate the distance between the new points and the points that belongs to a database in different classes. To define the new points class, those are the Euclidean distance, Manhattan distance, and Minkowski distance. So in the end, we can have a little bit difference between the distance calculation, but we get very similar results. The K nearest network can also apply the probability of one point belongs to a defined class. There's a conditional probability, and then as defined based on this equation here. So depends on the number of class that you have, the key that you want to compare, the probability will be computed by consider also the distance between the points. So let's see an example that we have a list of equipment in a plant, a refinery plant, and then we define the frequency severity detection of each equipment and the criticality, concerning, of course, the worst failure scenario of each equipment. And then, of course, we define as catastrophic, moderate, and different the classification. Now, what we want to do is that we are collecting some data set with critical classification of such equipment, and then based on the machine learning principles that we will split this data set in 70, 30% or 80, 20%. We'll get the 70%, the training data, the training the model, the K nearest neighbor will learn how to classify equipment in critical and catastrophic, moderate, and indifferent. And then when I input new data sets, such criticality will be classified automatically. So that's an example, practical example that I already demonstrated in the beginning, and that's the type of classification graphical demonstration that we have. Remember that criticality is that we are defining here is the product of frequency, severity, and detection, and we need to be aware that the frequency may change from time to time if we apply quantitative data based on reliability calculation. So based on it, we can have a function of failure rates that is the frequency of the failure of its equipment. And then as long as such data is being updated, there will be a new critical classification. This type of solution we would like to implement in what we call Asset Management 4.0, that have as a basis the asset management intelligence that enable the system give such information and some to the asset manager or maintenance expert to enable them to look on the assessment and focus the efforts in assessment, not to collect and make this classification. To be honest, in a refinery plants, refinery that have a lot of plants and equipment, there are daily basis necessary. It's necessary in daily basis to classify equipment criticality, and that is a very a huge effort that many maintenance experts put on it. And then, of course, if you can mitigate that, is quite good. If you have artificial intelligence tools behind that can make this critical assessment and classification automatically based on updated of the frequency that comes from the frequency function concerning the type, the reliability, and that will be very good. And in the end of our analysis, we need to verify the result of our model, and then we are looking on the positive, the number of data that were proper classified. So in this diagonal here, I can see all the data there were proper classified, 40 were proper classified as catastrophic, 60 were proper classified as indifferent, and 30 was proper classified as moderate. Then, of course, I can calculate different index such as accuracy. So accuracy is this is performed by this equation that I divided true positive plus true negative divided for true positive plus true negative plus false positive for false negative. So in total I have in 130 data in this diagonal here, and then of course I have no false positive or negative classified, so I have 100% accuracy. However, I have another index that I can use, such as recall. Recall is calculated for the rate between total positive divided for total positive plus false negative. In this case, as I have no false negative, I have 100% in my recall. And the other index is precision. That's total positive. That is represented by this equation. That is calculated based on the total number of positive calculation divided for total number of positive plus false positive. So I also get 100%. The other verification is the ROC graph, the areas under the curve, and then I can see here that I get the best resolution. That's when I have this point in here in the top of the graph on the left side. So the ROC is a receive operation characteristic, and this graph shows the performance of the classification model in different classification threshold limits. So basically they consider the true positive rate and false positive, and I calculate the true positive rate by using this formula here. True positive divided for true positive plus false negative, and false positive rate is calculated by this equation. False positive divided for false positive plus true negative rate. That is 0. Later on, we can get a new equipment with another refinery plants that also have towers, heat exchanger, and pumps, and then we can classify such equipment. Here is very interesting. That's the frequency of failure that was classified at the beginning change when compared to the first plant, because in this example the pumps have a high frequency of failure, and then they're not more classified as indifferent as in terms of criticality, but moderate. And then we want to check if our machine learning algorithm will considering that, or you just classify the pumps as indifferent. And then by using that, we can validate our model. So what we have here actually is what we classify in here. So we can see we have two C and the other M's. So exactly what we've got in the end by applying our validation, our previous model that was the K-nearest neighbor method, that model that we use for the first data set, show the second data set, the second plant criticality assessment, and then that proves that we can, after that, implement automatically this criticality classification. And then, of course, we get our graphs that show the different equipment, how they are classified in terms of criticality, and the area under the curve, that's ROC graph, and so on. So in order to perform this type of K-nearest network model, let's take a look on the MATLAB how we can do in our daily basis if you want to define a model to classify data in categories, and how we can do that by using MATLAB. So basically we need to apply the software now a little bit more complex algorithm that we read the file criticality. Then here the difference is that in the second level we need to define that we have a categorical classification. Now we are using classification methods, the characteristics. We have the third line here, the code that we are split our data in 30-70% for training and test data. We need to define which are the variable for data training and the test training. Then we put our function K-neural network here for the data training, and consider the class. We consider 5 nearest neighbors, and then we use this square distance for calculate the distance, and then in the end we calculate the error for the training and the data set. And then in the very end, after we perform that, we are using also the APP to get this function, and then we are able to use this function to predict the new data set classes. That's what we are demonstrating here by using this model. So our first step now to implement the K-nearest neighbor in the MATLAB software based on the command windows is to import our file. So that is the first step. We have a file with the equipment criticality list, and then our objective is, first step, we need to import this file. So we just go to our database and get our file inside the MATLAB. So we import now, the file will open, then we confirm and file, and the file will come out in the left right side of the template. So here we are. I did not put the name of the equipment, but I have the reference of 120 equipment here with all different classification of criticality. So again, the criticality is the combination of the frequency, severity, and detection, and then multiply these three numbers, I will get the criticality. And then of course, since this exercise is about classification, for each criticality I will put a class. So we have 3 classes: C as a catastrophic, M moderate, and I and E as indifferent. So we have it here. Okay, so I just import my data. If I close it here, I will see that here in my template my file is appeared. So my first step now is to read this table, this matrix here, and I call as a matrix A. So here we are. The matrix A have all the classification numbers inside. Okay, so now what I need to do is to define that the categorical class on my matrix that I'm going to do now. So this is my next command here. Below I will include the categorical and define that I have a class exercise. So here we are. We have now defined the classification of the class, and my next step will be to define the training data set and the test data set. Of course, before defining the training data set, what I need to do is to split my data set in 70-30%. So remember when I mentioned that the supervised machine learning classification is follows the general concept of machine learning methodology, that is to split your data sets in training and test data. Then I need to identify that based on this commands here. And here you see that is defined my data set is split is defined in here. So next step, now I define the data training and test. So now I'm defining the data training file, data training matrix. Now I define the test data matrix. So here is the data test variable. So I define the data test matrix here. Now I'm starting to define the k-nearest network function. Here we are. That is my KNN function, and that will use the data training. Next step now is to define the number of k nearest neighbors that we use. I define 5 nearest neighbors to compare the distance of a new point to this data. And then the next step is to define the distance, the equation to calculate the distance, the Euclidean distance. Then the algorithm will be able to proceed in comparing the new point distance for 5 nearest neighbors and define the class of the data, new data. In our case, is the criticality of the equipment. So here we are. Just set up the command here. And I defined the main square distance. Now what I'm going to do is to predict the class of this database. So, and then of course I use the k-nearest neighbor function, and I define the class for the data train. So I have 130 data in my file, and now I will define this 91 class what I have as a training data set. So when I implement this function, so automatically I will come out with the prediction of the class. And then after that I will predict the test class. So here we are, we have the 91 categorical class prediction, and if I click here, I will be able to see the prediction of '91 of this 130 data. So if I look on here in this matrix, I have 130. So what I've done when I got the training data is to get 91, 70% of this 130. And now what I'm going to do is to predict the, let's say, the training data sets. So I use the same function that I have here. Just be careful that what we need to do is to change the name. Let's put predict class 1, and here we put test. Now they will predict the 39 category for the test, the other 30%. So here we are, the prediction of 30%. That's the 39 class. So now the next step to calculate the error of the training data sets and the error of test data sets. So now I just put the error calculation for the training data sets, that's 0, and I will now predict the error for a test data set. So here we are, the error is also 0. So that means I have 100% accuracy. So I implement the whole k-nearest neighbor model by the command, but I can also use the APP. So by APP, as we already saw before, I have different options of machine learning here. We already use the neural network clustering for a self-organizing map. We already use the neural network for classification. Now we use the classification learning. So the first step in the classification learning is to get this file from here, from the workspace. You see that when open the first template, the first actions that I need to implement is to get this data set. So here we are. We have new section. I can get from file my data set direct from file or from my workspace. So I already have the criticality 1 file there. So I want to get from the data from my workspace. So I need to select my matrix here, and then what's going to happen is that the software select automatically the class that I want to use. So that's categorical that I define in my code command. That we have the class critical, catastrophic, moderate, and indifferent. Now I have all the columns here. So what I'm going to do now is to split my data sets in 37%. So I'm doing the same working by using the applicative, the APP here, but now I will get the graphs, and you see how does it work by using APPs is faster than when I put command. Is also easier. The another point by using APP is the possibility to import the functions, the function for the command place where I used to implement the k-neural network for new data sets. But let's go by parts. So here, the first cross validation, is the option that they use 5 times split the data sets in order to have more reliable results. That's a setup of the software. And then the other option here is that where I split the data. So the setup is 75% of the data sets is allocated to training. Is that data training, and 25% are test data. But let's put 30% to be the same that we had before as we set up the command. And I will not put any protection against overfitting. I just start my section, and you see that a graph will come out in this area. That encompasses the data of my matrix, but that will shows up graphically. So, and that's what we've got. The software are organizing my data set here, and we have different categories here. So I have severity by frequency. I can change the variable that I have in the x axis and y axis. This graph could demonstrate only in 2 dimensions, so I need to choose how I will represent my graph. So basically I will use criticality, and then I have frequency by criticality. That's basically the frequency is the parameter that will change along the time, and then I would like to see different um, uh, frequency, different graph that concern frequency and criticality. That's the criticality mostly change based on the frequency changing. So another very important aspect is that here in this graph I do not see 130 points, and that's why most of the points have a similar criticality and frequency. That's why I do not see many points allocated here. So that are the reasons. So here, for example, if I click here, I have 30 observations that have a frequency 5 and criticality 125. So here, if I put in here, I have 10 observations that have a frequency 5 and criticality 100%. And if I go further on, I can see that I have here, for example, 10 observations that have frequency 3 and criticality 3. So that's why I do not see this 130 data here, because they have the similar frequency and criticality. Okay, so now that I have my data set organized, very important to see here what means the colors of each one of the class. So I have a catastrophic blue. So these are the catastrophic one that have higher criticality. Those are related to vessels, towers, tanks, and so on. Here I have indifference. Indifference are the lowest criticality are the pumps, and M are moderates, that are the heat exchanger, for example. So now what I'm going to do is to use the K nearest neighbor model. So I have a lot of models here. You can see we'll go one by one. I choose one K near neighbor. You saw that we have different K near neighborhoods. We applied the simplest one to demonstrate it here, and then we set up to train the data. So as long as the software, the algorithm is running, the algorithm return back to the first template. That is the template that we put the command. And when they finish that, they return back and show the graphs, and we will be able to see the real value and the predicted value. If we really achieve this zero error in the training data set, that means that we are achieve 100% of accuracy, and this accuracy is also demonstrated in there. Another important graph that is demonstrated is the confusion matrix that is plotted automatically, as well as the ROC that are also plot automatic. And then, of course, in the end, I will be able to export the model and input here a new matrix with a new data set, and use the previous model, this model that I have 100% accuracy with a new data set, and see how does it works. So that's the general concept, how machine learning works, for how this supervised machine learning classification works. So here we are. Now the model is still running. I do not have, here you can see I have only the data that I had before. When the model finish here, they will demonstrate the error, and I demonstrate that model prediction. So here, as I mentioned, we achieve 100% of accuracy, and I have no mistakes. So I have here correct and incorrect classification. I have no incorrect classification. Then I achieve 100% of accuracy. So here below, I can see some information about the model. The distance metric is Euclidean, and so on. And now I can look on my confusion matrix. If accuracy is 100%, I expect to have only true positive classifier. So here we are for this data that we have here. I have only true positive data classified. So remember that I do not have this 130 data, because many of them are the same. So they classify all of the data that has previous classification as catastrophic. They are really predicted as catastrophic. The 18 that are predicted as indifferent are classified as indifferent, and the 9 that's moderate are classified as moderate. So I can check the calculation of true positives here. True positives, you can see here that shows 100%. Remember, that's the calculation that demonstrates true positive is the true positives. The accuracy is the total true positive for true total for true positive for true negative divided this relation that we have between true positives, true negatives, false positive, and false negative. That comes out the accuracy. So, but here the software is display the information automatically. You can see if you have a false negative or true true negative, they would include in here. The other important aspect is ROC, that shows the relation between the true positives and false positive rates. So we got the area under the curve is 100% covered. This point shows that I have perfect fit of this curve in here. And then there's another important information. So let's come back to our plot and let's export our model now. Now I can export by using the previous data or not. So the idea to export this algorithm here is to use to predict the new database. So if I export in here, so I have the option to export. If I go to my previous model, I will see the previous template that I have the command window. I will see that this function was input in there, and then I can import a new, let's say, a matrix, a new data set with new other plants, equipment, list of equipment criticality, and then the idea is that the model classify such information automatically. So let's take a look and see how does it works. So here we are, the function that the system gives to me. So what I'm going to do now is to import a new matrix data. So I go to classification here, my file, and import this matrix 2. So if I look on the matrix 2, I will see the classes that I expect to have in here. Then I import. So this matrix is here, and what I'm going to do is to use this function. This function is automatically inputting here based on the app that produced this model. And then I just type in here the new input data that I have. And then when I click in the enter here, I will get this classification. Then by comparing what I have originally, I have two misclassified data here. So and then that means that I need to improve more my model to get a better, let's say, a better, to minimize this error. So that's the general concept of nearest neighbor model. So let's move and finish and get some conclusion about the K nearest neighbor model. So let's make a conclusion about the K nearest neighbor model. So like other models, we have advantages and disadvantages to use this model. So it's a very simple model to implement, robust regarding the space distribution of the data, simple classifier updated, and only distance metrics and K as a parameter to adjust. So the K is again the number of neighbors, and the distance by using or Euclideans distance or Manhattan or other distance measurements are the key functions that we use for this model. The drawbacks is that expensive testing for each instance, as we need to compute its distance to all known instances, and sensitiveness to noise for irrelevant attributes, or for example, if you have a type of data set that have a lot of boundaries among the classes, and sensitiveness to very unbalanced data set is what I mean. If you have a data set that is not quite organized in space, so probably I have misclassification. So this method is also in our book, Artificial Intelligence for Maintenance 4.0. If you get details information and read the test and see the examples, you can find in our book. So thanks for your attention. We'll move to the next model. If you have some question, please just send us your question.